Okay, so this is problem number 6 in chapter 11, quiz review, the harder problems. Okay, so we start with a hexagon. All right, and regular hexagon has the area of 36√3. Find the radius of inscribed and circumscribed circle. Okay, so let's start with this. This is what you learned in chapter 9, the inscribed and circumscribed, but just to refresh your memory. This is the radius of hexagon, right? And this is the apothem of hexagon. The radius is from the center to the vertices of the polygon. The apothem is from the center to the midpoint of the side, right? That's the apothem. That's the radius. Radius of the polygon is the radius of the circumscribed circle. Okay? So radius of the polygon is the radius of the circle outside the polygon. The apothem of a polygon is the radius of the inscribed circle. Okay? So when you're looking for the radius of inscribed and circumscribed, this is the apothem and this is the radius. Okay, so that's what you're looking for. So when you find the apothem and radius of this hexagon, you found the answer for these two problems. Okay, so let's just erase this so we have a cleaner diagram. And let's start with hexagon. And remember, the hexagon is the collection of 6 equilateral triangles. So if this total area is 36√3, each of these area is 6√3, right? Each of these is 6√3 areas. Okay, so then what we are dealing with trying to find the base and the height of an equilateral triangle with the area of 6√3. Then we go back to basically the same problem as the 1b that hope maybe you just saw. So again, you can do two ways. You can call this a x, then this is √3x, right? So the area of this triangle is x times √3x, which is this. So that's x squared √3 equals 6√3. √3 cancels. X squared is 6. So x is square root of 6. And you have two of these, right? So 2x is 2√6. And this is the side of the triangle, which is the radius of the circumscribed circle. So this is radius of circumscribed. Okay, and then the apothem is the square root of 3 times x. So square root of 3 times square root of 2 is, I'm sorry, square root of 6. X is square root of 6. So square root of 3 times square root of 6. There are 1 3 in 6, right? It's a 6 times 2, so 3 comes out. 3√2. This is radius of inscribed. And don't forget the units, that's centimeter and centimeter, okay? 2√6 and 3√2 centimeters. I don't know if you can see it. Yeah, you can. Okay, and the other way, I'm going to show you the other way. So again, you have a triangle and you know the area is 6√3, and this is 1/2 of base times height. Okay, so did we multiply both sides by 2? No, you did. All right, so let's just stick to that method. So if this is b, then 1/2 of the b is this side. So this apothem is square root of 3b over 2. Square root of 3. I don't know if you can make this a little closer. Is that better? Yeah. Square root of 3b over 2 would be the apothem. which is the height, so you can replace it. 6 root 3 is 1/2 of b times square root of 3b over 2. So there's a 2 in the denominator, so it's 4. 1 square root of 3, and then 2b, so b squared is 6 root 3. So you want to isolate b squared, so you multiply by reciprocal of this on the other side. So 6 root 3 times 4 over root 3. Root 3 cancels, and 6 times 4 is 24. So b is square root of 24. There's a 4 in here. So 2 comes out, 2 root 6, because this is 2 times 6, right? Centimeter is the radius of the circumscribed circle, and 2 root 3 times, 2 root 6 is a b times square root of 3 over 2, right? Yeah, because the apothem, or the radius of the inscribed circle, is b times square root of 3 over 2. So you have to do this. 2 cancels. So this is square root of 6 times square root of 3. This is 3 and 2. So 3 comes out. 3 root 2 centimeters. You get the same answer. Whichever you prefer is fine with me. Okay?